Let's take a look at protein hydrolysis and denaturation. Okay, so protein hydrolysis is when you break the peptide bonds to yield the individual amino acids that made up that chain. Okay, where we see this in the body is with food digestion in our stomach. The enzymes in our stomach start breaking down these peptide bonds through hydrolysis reactions, and it gives us those individual amino acids. Okay, so it's breaking the primary structure. Okay, breaking apart those covalent peptide bonds. Okay, denaturation methods is where you disrupt, you alter, you change the secondary, tertiary, or quaternary structure of the proteins. Okay, and there are some ways you can do that. Okay, we can do it through the use of heat. Okay, and heat around 50 degrees Celsius is considered the temperature where proteins kind of lose their active or biological activity nature. So around 50 degrees Celsius on that. Okay, the heat will disrupt things like hydrogen bonding, hydrophobic interactions, the different tertiary forces, or the different forces that make up the tertiary structure and so forth. Okay, pH change. Okay, so if we change the pH of the protein's environment, we can do this by the addition of acids and bases. Okay, if we think back to amino acid classification, amino acid R groups can be classified as polar, non-polar. They can be classified additionally as neutral or acidic or basic. So if we add acids or bases to our protein samples, then we can change hydrogen bonds, we can change salt bridges, we can change those forces, and we disrupt the secondary, tertiary, and quaternary structures of the proteins. Okay? With organic compounds, think of all those compounds that you aren't supposed to drink, that you're not supposed to consume. Things like alcohols, esters, ethers, antifreeze, acetone, all these various organic compounds that are very poisonous, and you have to call the poison control center. Well, organic compounds can disrupt things like hydrogen bonding in the bacterial proteins. Think of like ethanol and isopropyl alcohol, which is rubbing alcohol. We use those little cotton gauze alcohol pads to clean wounds and cuts. People also consume ethanol, and alcohols, for example, are really great at being polar, so we can have those hydrophilic interactions. We can also disturb the hydrogen bonding interaction, because alcohols are capable of doing hydrogen bonding, and we get those disruptions in our protein structure because of the organic compounds that come in. You may get a compound, you may consume a compound that's non-polar, things like hexane that are polar, or like gasoline additives lots of times are non-polar. So you consume those, and non-polar solvents and consumption could disturb those hydrophobic interactions with those R groups. And then we have issues with heavy metals. We often think of lead poisoning as a big deal. Mercury poisoning. One concern is mercury levels and heavy metal levels in shellfish and seafood, and then consuming those fish products. Heavy metals come into the body oftentimes in ion forms, so in charged particles, and heavy metals like to be positive ions we call cations. Well, think back to the structure of amino acids with the R group specialized, the alpha carbon, your hydrogen, your carboxylate group, and your ammonium group. Well, when you start to introduce positive ions into the protein structure, you can see where the positive ions may interact with these charged groups. They may also interact with the R group. If you think back to acid-base reactions, those lead to salt bridges. Well, salt bridges are the interaction of ion charges, and here we are introducing more ions there that can disrupt those bridges. Okay, you can even disrupt the disulfide bonds that you see in those thiol groups of cysteine. Okay, so heavy metal disruption or denaturing of the protein. And then finally, agitation. Think of agitation as like physical means of disrupting the protein structure. So we're disrupting like hydrogen bonding, hydrogen-phobic interactions. This may think of, as your book describes, a whipping cream, egg meringue, where you use the electric beaters or mixers to stir and fluff the proteins, and it becomes that white fluffy meringue kind of structure. So agitation is by mixing, whipping, stretching mechanically, so say pulling the structure to disrupt its secondary, tertiary, quaternary shape. You know, some of the common methods are common things we use to denature proteins. You can think of meat tenderizers and marinades that we use to soak chicken or beef or pork. We soak and use the marinade rubs on the meat that soak in and then tenderize the food, the meat, by denaturing, by disrupting these protein structures.